Hi my friends, today we model this nice part and this is the drawing. We start by creating this contour with all dimensions, radius 103, 125, radius 38, radius 9 and this distance of 139. The thickness will be 24. This part is number 41 and it is from my collection of 100 parts. New empty document. Take a look of this workbench and select CAD, not Blender, because we create mechanical parts. New sketch, XY plane, then polyline. Vertical MMM, once again MMM, and another one going vertical to this point, MMM, you know this procedure. You must use the key M from the keyboard and not once but twice, MMM, and I go here. We have not tangency here and here. Tangent this, tangent this. You see the marks for constraints all around, including vertical and vertical. This point is placed on this axis. Also this is placed here. This point must be placed on the vertical. Then equal of this arc and this arc. The radius is 10. This is 103, the radius. Equal are also these two arcs, and symmetrical this and this with the axis. This must be larger, and we place a dimension here of 139. This distance, no, this radius is 30. This radius is 38. This radius is 90. Then we have a dimension between this point and this point of 125. I don't see what is the last one. Oh, I know. This distance with the center point is placed at 87. Now we have a fully constrained sketch. We use the key 0 to apply this isometric tool, then this to place in the graphic space. Pad or extrude on 24. Then we apply the fillets of radius 3 all around this contour because of these bosses. We select only one edge and we apply fillet of 3, not 1. Good. Then we create these 4 bosses. They are placed with the center in the center of this radius, and distance is 97.35, and we have to take a look here. 28 is this all dimension if we consider this face. Okay, new sketch, XY plane, and view section. We have this point, very important, and we project these 2 small arcs. Circle here, another one here, and other 2 equal with the same radius of these 2. Symmetric, this center with this axis, and dimensions, this is 97. We project also this arc and we place the dimension of 35. This is 35. Close. That sketches are on the bottom, yes. We apply pad, we rotate the cursor, the wheel of the mouse to see what is the direction, and we place here 28. Zero and view. Now we create this feature, a cylinder with diameter of 57 and the hole of 46. New sketch in the same plane. Then we project this arc, view inside, we have this center circle of 57, close. Once again I apply extrude, I rotate the wheel of the mouse until we see this. The value from the bottom, not from this face, is 67. Then I select this, and without any other intervention I apply hole. How much is the diameter? 46. And what is the dimension? Through all. Okay. Next is this feature without the hole, with dimensions 56 at a distance of 80 from the bottom, then 35 and 75, radius 6 here. New sketch, YZ plane, view section, and we draw that contour. Vertical, left, down, left, then MMM to here, and MM to use a vertical line and back to the start. Here is not tangent, we apply tangent. Dimensions, this is 56 divided by 2, this is 35 divided by 2, this is 6, then 80, and 75. Fully constrained, close. We apply revolve, and we have the result because the default axis is vertical, and it's also the Z axis here. This is why it is important to select the center point when you start a sketch. Yes, you see, you obtain something by default. Okay, now we create this sketch on the bottom for a cut of 18, dimensions 64, 125, radius 6. We turn back the part, we place here a sketch, a circle with this center, diameter of 125, then project this circle to create another one with diameter of 64, trim of this segment and this segment and we apply fillet. I want you to see something interesting. If I select at a distance from this point, I have this arc. When I select from near that point, we have another dimension of the arc. We make them equal, of course, and the radius is 6. Green all over, close, pocket of 18. Okay, 0 and view. Next is this internal revolution volume with dimensions 30 and 14 degrees for this cut at a distances of 2.8, 4.5. Then 35 at 72, 3 millimeters here, and 69 for this end. The other dimensions are 47 for this channel and 46 for this cylinder. We apply all these dimensions. Another sketch, once again in this plane, view section, and we draw some lines. But firstly we project this polyline starting from the center up to the projection, then we go somewhere here, down, sloped, down, sloped, vertical, horizontal, vertical, horizontal, go to the bottom and back to the start. We have a close contour, this is for sure. Now dimensions. This point is coincident with this line. Equal are these two small lines, and 14 is the angle. Then dimensions, radii. This is 22.5 divided by 2. Then this is 30 divided by 2. And this one is 35 divided by 2. I forgot that channel. I eliminate this line. I draw a small vertical line. I go here and to the bottom, vertical line, and here. I suppose this is okay. No, it is not. Because I didn't see this coincidence. Good. Now this is 47 as you remember, 47 divided by 2, and the other is 46 divided by 2. Good. Now we have that dimensions. 2.8 is this distance, 2.8, and 4.5 is the other one, 4.5. Then dimensions to the bottom. This is 72. This is 69. This small is 3. And we have to move this to be horizontal. You see, this is not horizontal. I ignored this. Now it's horizontal. What is the missing dimension? This is 23. 46 divided by 2. Everything seems to be okay. What about this or this? No, this is wrong. You see, this point is not coincident with this. Coincident point with point. Good. Close and groove. Once again, the axis is vertical and default. Okay. Now we have to create this 1, 2, 3, 4 holes with diameters of 10 all the way through these bosses. Then this counterbore diameter of 6.5, diameter of 14 and 3, placed at a distance of 64 and 24. And the last are these holes, metric 9, through the part, distance 11, distance 97. Let's create all these 4, 6, 8 holes, different models. We simply select these faces. I press the Control key on the keyboard to select all these 4 faces. Then hole, diameter of 10, dimension through all. Okay. Then we select this face. For a new sketch, we place 2 circles, 1, 2. They are symmetrical about vertical axis. The distance on horizontal is 64. We project this circle and we place another distance of 24. Close, hole, internal diameter is 6.5 through the part, then counterbore of 14 on 3. Okay, same face for another sketch. 2 circles, 1, 2, symmetrical, this point above this axis. The distance on horizontal is 97. We project again this circle and we apply dimension of 11 between these two on vertical. Close, hole, isometric regular profile, metric 9, dimension through all, and threaded. If you want, you can apply this model thread, but it will take a time, as you will see right now. Okay, we have to wait because it's generated the real thread inside that 2 holes. Still working, you see. Still working a lot. Now we see here that profile. Last are these undimensioned fillets of radius 3. You see they are in many positions, so we have to be careful with them. We select this edge, then we press the Control key to select this edge, this edge, this, and also Control key pressed this. Now you see that edges, fillets, the problem is with this, the time to be very long. This is 1, but we want 3. Again, we have to wait. Everything is recalculated. Now you see this. We go here and we select this, then press the key from the keyboard, the key Control from the keyboard. When you select these edges, once again fillet, we have to wait. And to apply 3 instead of 1. Once again, we wait to apply that fillets. That's all for today. Thanks for watching. Bye bye.